Hello? Hi! We're here. Let's do this. Okay, no wings today. Good time of day, whether it is morning, evening, afternoon, or even midnight. Okay. Oh, I was supposed to be talking like this. Yes, mic is good. You should be able to hopefully hear me. Can we double check on that? What's with the music? Is there music? No. Cool. Wow. Amazing. Okay. Let's do this. We left off. I really like the headphones today. They even go transparent because they change color, and one of the colors is green, and green is chroma keyed out. So so cute. Okay. Yes. Where were we? We were able to yesterday. I think, yes, amazing. We were able to load the train.csv file, just look at it for funsies. This is cute. And yeah, same almost. We had the display function, we ran it, which was a part of all of this. But then there was an error. I don't think there was an error. I think no. I closed the YouTube thing. Shoot. Wow. I'm having what do you call it? I am having goldfish memory because I was using Kaggle and I had no issues. That's why I was like so excited to start again today. Yeah, display all worked fine, and I was here, but before I ran this, I wanted to fast.ai there. I wanted to finish watching the video. So let me go to my YouTube channel. YouTube. Just go to YouTube and continue fast.ai. If I go to my history tab, we should be able to see it pretty soon. Yep, found it. Still lesson 1, and let's watch it together. And I should unpin the starting in 10 because we have started. Okay, we were in the I think, yeah, random forest part starting, so I'll go back like a bit. Just an FYI, I may only be able to stream for 1 hour today, compared to yesterday and the day before yesterday, where I was streaming over 2 hours. Okay.
By the interactions,
Back a bit.
It doesn't assume that in general, overfit, whatever. Pixel can predict it with columns
looking at
of
your data.
pretty much
I think this was
kind.
the part.
Pixel
Student
data,
test,
zip codes,
random forest,
revenues, whatever.
Sorry, one more check for my sound. Sorry, one more check for. It's fine. Could be. I could do better, but we're okay.
In general, it doesn't overfit. It can, and we'll learn to check whether it is, but it doesn't generally overfit too badly, and it's very easy to stop it from overfitting. You don't need, and we'll talk more about this, you don't need a separate validation set in general. It can tell you how well it generalizes, even if you only have one data set. It has few, if any, statistical assumptions. It doesn't assume that your data is normally distributed. It doesn't assume that the relationships are linear. It doesn't assume that you've specified the interactions. It requires very few pieces of feature engineering for many different types of situation. You don't have to take the log of the data. You don't have to multiply interactions together. So in other words, it's a great place to start.
Good
Right?
beginner
If your
thing.
first random
Hello,
forest does
Mr. Mustafa. What's up? You're here early. Yeah, continuing where we were yesterday, and cute angel emoji. Yeah. Yesterday was fun, so I wanted to I had energy to come back today, even though it's a work day.
has very little useful, then that's a sign that there might be problems with your data. Like it's
I'm
designed
good,
to work.
and I
pretty
think
much
the
first off.
latency
Can you please throw it at or
is better than yesterday, hopefully. My internet says she's doing great, so yeah, I'm okay. I'm really good today, actually. Yeah, thank you. Do you like the new headphones? Oh my god, look at it. I didn't know there were hearts on the sides. Thank you. Okay. I will start playing, but if you have any questions, or if at any time I ask for your help, that would be nice. You don't have to stay, by the way. In a way, I did, but yeah.
first random forest does very little useful, then that's a sign that there might be problems with your data. Like it's designed to work pretty much first off. Can you please throw it at or towards this gentleman? Thank you.
What about curse of dimensionality when using random forests?
Curse
Yeah,
of
great question. So
dimensions.
there's this concept of curse of dimensionality. In
The
fact, there's
bigger
two
the worse,
concepts I'll
right?
touch on. Curse of dimensionality and the no free
shit.
lunch theorem. These are
Free
two
lunch?
concepts you'll often hear a lot about. They're both largely meaningless and basically stupid. And yet, I would say maybe the majority of people in the field not only don't know that, but think the opposite. So it's well worth explaining. The curse of dimensionality is this idea that the more columns you have, it basically creates a space that's more and more empty. And there's this kind of fascinating mathematical idea, which is the more dimensions you have, the more all of the points sit on the edge of that space. Right? So if you've just got a single dimension where things are like random, then they're spread out all over, right? Whereas if it's a square, then the probability that they're in the middle means that they can't have been on the edge of either dimension.
What does that mean?
Less likely that they're not on the edge. Each dimension you add, it becomes multiplicatively less likely that the point isn't on the edge of at least one dimension, right? And so basically in high dimensions, everything sits on the edge. And what that means in theory is that the distance between points is much less meaningful. And so if we assumed that somehow that matters, then it would suggest that when you've got lots and lots of columns and you just use them without being very careful to remove the ones you don't care about, that somehow things won't work.
Is it true?
That turns out just not to be the case.
Awesome.
It's not the case for a number of reasons. One is that the points still do have different distances away from each other. Just because they're on the edge, they still do vary in how far away they are from each other. And so this point is more similar to this point than it is to that point. So even things we'll learn about k-nearest neighbors actually work really well, really, really well in high dimensions, despite what the theoreticians claimed. And what really happened here was that in the 90s, theory totally took over machine learning. And so particularly there was this concept of these things called support vector machines that were theoretically very
I've heard that, but I don't know what they
extremely easy
are.
to analyze mathematically, and you could like kind of prove things about them. And we kind of lost a decade of real practical development, in my opinion, and all these theories became very popular, like the curse of dimensionality. Nowadays, and a lot of theoreticians hate this, the world of machine learning has become very empirical, which is like which techniques actually work. And it turns out that in practice, building models on lots and lots of columns works really, really well.
Cool.
So yeah, the other thing to quickly mention is the no free lunch theorem.
The more columns, the more information about what you want to predict. So I see the point.
There's a mathematical theorem by that name that you will often hear about that claims that there is no type of model that works well for any kind of data set. Which is true, and is obviously true if you think about it in the mathematical sense. Any
Hey, Danny's here. Thank you. Yes, and at some point you'll find strong correlation between variables which increase the training time without adding that much of accuracy to the model. That's cool. No! Good question, Danny. So I am doing well. I'm doing pretty good. Yesterday, things went so well that I got motivated to to actually stream on a work day. But I'm going to stream for only an hour, so because I actually want to be able to run the model and all that. So I worked on it on Kaggle with our friend Mustafa here. Yes, but it is a work day today. Thank you for you. Yeah, remembering that. The solution to this problem is dimensionality reduction. Thank you. By the problem, do you mean? Yeah, it makes it faster, but not having enough information may also hinder it, right? It's probably a balancing act. I really like my headphones today, by the way. They're cute. They change color. There are like 3 others with this style, but I went for black. I may go for another color another day because the black looks a bit hidden. Okay. Let's see what he's talking about with the lunch theory thing.
And it's obvious for there is no that you will often hear about that claims that there is no type of model
reduce the number of
that
columns.
works well for any kind of data set.
Probably you will.
Which is true, and is obviously true if you think about it in the mathematical sense. Any random data set, by definition, it's random, right? So there isn't going to be some way of looking at every possible random data set that's in some way more useful than any other approach. In the real world, we...
Yeah, reducing number of columns without losing information is definitely understanding the data before, like processing it and all that before running the model. So yes, that is a step that it has to be done, but I think in this first lesson he's just saying let's run the things for now and use model like random forest. Because it works with a lot of different types of data, right?
We look at data which is not random. Mathematically, we'd say it sits on some lower dimensional manifold. It was created by some kind of causal structure, right? There are some relationships in there. So the truth is that we're not using random data sets. And so the truth is in the real world, there are actually techniques that work much better than other techniques for nearly all of the data sets you look at. And nowadays there are empirical researchers who spend a lot of time studying this, which is which techniques work a lot of the time. And ensembles of decision trees, of which random forests are one, is perhaps the technique which most often comes up the top. And that is despite the fact that until the library that we're showing you today, fast.ai, came along, there wasn't really any standard way to pre-process them properly.
Really?
And to properly set their parameters. So I think it's even more strong than that. So yeah, I think this is where the difference between theory and practice is huge. So when I try to create a random forest regressor, what is that? Random forest regressor. Okay, it's part of something called sklearn. sklearn is scikit-learn. It is by far the most popular and important package for machine learning in Python. It does nearly everything. It's not the best at nearly everything, but it's perfectly good at nearly everything. So like you might find in the next part of this course with your net, you're going to look at a different kind of decision tree ensemble called gradient boosting trees, where
Don't know what
actually
that
there's
is.
something called XGBoost, which is better than gradient boosting trees in scikit-learn. But it's pretty good at everything. So I'm really going to focus on scikit-learn. Random forest, you can do two kinds of things with a random forest. If I hit tab, I haven't imported it. So let's go back to where we import. So you can hit tab in Jupyter Notebook to get tab completion for anything that's in your environment. Okay. And you'll see that there's also a random forest classifier. So in general, there's an important distinction between things which can predict continuous variables, and that's called regression, and therefore a method for doing that would be a regressor, and things that predict categorical variables, and that is called classification, and the things that do that are called classifiers. Right? So in our case, we're trying to predict a continuous variable, price. So therefore we are doing regression, and therefore we need a regressor. A lot of people incorrectly use the word regression to refer to linear regression, which is just not at all true or appropriate. Regression means a machine learning model that's trying to predict some kind of continuous outcome.
Yeah, honestly, and if I hadn't taken that data science course, I probably would be lost now. So the whole categorization versus regressor or regression being the output or outcome that we want, whether we want it to classify something, like tell us, is it, what color this thing is, so that would be the outcome, or do we want a number, a continuous number, not just one number, because if it's 0 or 1, or even if it's set thing, it's still a classifier. But if it's a continuous number, then that becomes regression. So recognizing that is also important for me, because in a way I am still a beginner. Okay, let's continue.
As a continuous dependent variable. So pretty much everything in scikit-learn has the same form. You first of all create an instance of an object for the machine learning model you want. You then call fit.
Exactly, rule of thumb, yep.
Passing in the independent variables, the things you're going to use to predict, and the dependent variable, the thing that you want to predict. So in our case, the dependent variable is the
price.
Data frame's sale price column.
Which
and
is
so
regression.
The thing we want to use to predict is everything except that. In pandas, the drop method returns a new data frame with
so that's processing our table, removing the thing we wanted to predict. So we're not even giving it the target column, because like I was using another tool and we would say this is a target column, but here we just drop it and give it everything else. Maybe, let's see.
To columns removed, right? Well, a list of rows or columns removed. So axis equals 1 means remove columns. So this here is the data frame containing everything except for sale price. Okay?
Okay. Do you run it?
Can I have the box, or can you throw it to Ernest directly?
The box is a
So
microphone.
if you want to remove multiple columns, you just pass a list of strings with column names.
Let's find out. So to find out, I could hit Shift-Tab, and that will bring up a quick inspection of the parameters. In this case, it doesn't quite tell me what I want. So if I hit Shift-Tab twice,
Shift-Tab
it
twice.
gives me a bit more information.
I didn't know that.
And that tells me it's a single label or list-like. List-like means like anything you can index. In Python, there's lots of things. By the way, if I hit 3 times, it will give me a whole little window.
That is cool.
Okay, so that was Shift-Tab.
Shift-Tab.
Another way of doing that, of course, which we learned, would be question mark,
I'm gonna test that.
Yeah.
Hold up. I didn't run this part, did I? Shift tab. Oh, it ran. I guess that doesn't work for you. But I think, is it? Nah. Nope. Shoot. It's fine. We can just do the question mark thing. Can I run this? Yeah. Okay. I need to like redo the whole session before I can start running the other things. That would be a bit boring, wouldn't it? For you guys. Yep. Deprecated. Going back. Oh, okay. Did I run that? Okay. And then are we there? Yes. No need. You. And then that should take a minute. Yeah, okay, so I can go back to you.
So drop. Okay. Sorry, question mark would be the source code for it.
Source code.
Or a single question mark.
One question, select a cell and then tell it to run. I did not know that. Where would I do that? Maybe something around here? Or maybe even in the run. There should be run before. We do have it. Okay, I don't see any shortcuts, but run before. I'll do that next time. Thank you, that was pretty useful. And you're still running, so do that. Question mark just brings the lower tab help manual thing. That's also pretty cool.
So I think that trick of like tab complete, shift tab parameters, question mark and double question mark for the docs and the source code. Like if you know
Wait, can I do this? Whoa, no I can't. No, I messed up. That's cool. It was nothing. Okay.
Nothing else about using Python libraries, know that, because now you know how to find out everything else. Okay. So we try to run it and it doesn't work. Okay.
Really?
So why didn't it work? So anytime you get a stack trace like this, so an error, the trick is to go to the bottom.
Yeah.
Because the bottom tells you what went wrong. Above it, it tells you all of the functions.
String could not be converted to something number related. Yes. Brings to pulls up the code function in the question. We can test that. Let's see if the display all works. Yep, it did. We are doing great. I can test that with no error. It was this. The guy was testing it with this. So we can also test that. One question should be the documentation. Cool. That's pretty long. It's the whole thing. 2 question. Oh, okay. Can I go back to 1 question? That's cool. That's cool. Even examples and all. Okay, that would be pretty useful. Let's see what his error was.
Functions are called other function could cause other functions to get there. Could not convert string to float, conventional. So there was a column name, there was a value rather inside my data set, conventional, the word conventional, and it didn't know how to create a model using that
column?
string. That's
or
true.
just this string?
We have to pass
Let's see.
numbers to most machine learning models, and certainly to random forests. So step 1 is to convert everything into numbers.
Everything? Everything? No. Right?
So our data set contains both continuous variables, so numbers
That
where
should
the
be
meaning is
fine.
numeric, like price, and it contains categorical variables, which could either be numbers where the meaning is not continuous, like a zip code, or it could be a string, like large, small, and medium. Okay, so categorical and continuous variables. We want to basically get to a point where we have a data set where we can use all of these variables. So they have to all be numeric, and they have to be usable in some way. So one issue is that we've got something called sale date, which you might remember right at the top, we told it that that's a date, so it's been parsed as a date. And so you can see here it's data type, D
Date
type, very
time,
important
okay.
thing. Data type is date time 64-bit. So that's not a number.
Yeah, it's not.
And this is actually where we need to do our first piece of feature engineering. Right? Inside a date, there's a lot of interesting stuff.
Do we call data processing feature engineering? That's pretty fancy. Or is that a different thing?
All right, so since you've got the catch box, can you tell me what are some of the interesting bits of information inside a date?
Day,
time series pattern, I guess. So it's the time.
That's true.
Week,
I
year.
didn't express very well. What are some columns that we could pull out of
your
this?
time.
that
Year,
might be
month.
interesting?
Thank you.
Year, month,
And then the date.
the date as in, like, tell me it needs to be a number. Year, month, quarter. You want to pass it to your right and get some more, or behind you? Just pass it to your right. Here you go. You got some more columns for us?
Day of month.
Day of month. Yeah. Keep going to the right.
Day of week.
Day of week. Yeah.
Something else. The week.
Week of year.
Yeah, week of week.
Yeah. Okay. I'll give you a few more, like that you might want to think about. Would be like, is it a holiday?
True.
Is it a weekend? Was it raining that day? Was there a sports event that day?
How can we know that?
Like, it depends. Soda sales in Soma, you would probably want to know, was there a San Francisco Giants ball game on that day?
Good
Right?
point.
So, like, what's in a date?
There's a test, like beginner intro ML thing in Microsoft Learn, on the Microsoft Learn platform, and it's about selling lemonade, and knowing the weather is a good point, like a good feature to have, selling lemonade. Otherwise, maybe people won't buy it, like when it's winter.
Is one of the most important pieces of feature engineering you can do. And no machine learning algorithm can tell you whether the Giants were playing that day and that it was important.
Good
right?
point.
So this is where you need to do feature engineering. So I do as many things automatically as I can for you, right? So here I've got something called add date part. What is that? It's something inside fast.ai.structured. Okay. And what is it? Well, let's read the source code. Here it is. So you'll find most of my functions are less than half a page of code. Right? So here is something it's going to... So rather than having docs, I'm going to try to add docs over time, but they're designed that you can understand them by reading the code. So we're passing in a data frame and the name of some field, okay, which in this case was sale date. And so in this case, we can't go df.fieldName because that would actually...
Is it giving you each part of the information, like a year, month, weekday, day of week, day of year, is month end, is month start, is quarter end, is quarter start? Is it giving you that all back?
find a field called field name, literally. So df square bracket field name is how we grab a column where that column name is stored in this variable. Okay, so we've now got the field itself, the series.
And it's saying if it ends with the word date, doesn't it? That's cool.
Yes. And so what we're going to do is we're going to go through all of these different strings, right? And this is a piece of Python which actually looks inside
Get
an object and finds a attribute with that name. So this is going to go through, and you can Google for Python get attribute. It's a cool little advanced technique. But this is going to go through and it's going to find, for this field, it's going to find its year attribute. Now, Pandas has got this interesting idea, which is if I actually look inside, let's go field equals, this is the kind of experiment I want you to do, right? Play around, sale date. Okay, so I've now got that in a field object.
Okay.
So I can go field, right? And I can go field dot tab, right? And let's see, is year in there? Oh, it's not. Okay, why not? Well, that's because year is only going to apply to Pandas series that are date time objects. So what Pandas does is it splits out different methods inside attributes that are specific to what they are. So date time objects will have a DT attribute defined, and at that is where you'll find all the date time specific stuff. So what I went through was I went through all of these and picked out all of the ones that could ever be interesting for any reason, right? And this is like the opposite of the curse of dimensionality. It's like if there is any column or any variant of that column that could ever be interesting at all,
let's have it.
Add that to your data set, add every variation of it you can think of. There's no harm in adding more columns, nearly all the time. Right? So in this case, we're going to go ahead and add all of these different attributes. And so for every one, I'm going to create a new field that's going to be called the name of your field with the word date removed, so it'll be sale,
removed,
and then the name of the attribute. So we're going to get a sale year, sale month, sale week, sale day, etc., etc. Okay.
Cool.
And then at the very end, I'm going to remove the original field, right? Because remember, we can't use sale date directly because it's not a number. Okay. Can we pass?
So you're saying this only worked because it was a date type? Did you make it a date type, or
Yes.
was it already saved as one in the original one?
Yeah, it's already a date type, and the reason it was a date type is because when we imported it, we said parse dates equals and told Pandas it's a date type. So as long as it looks date-ish, and we tell it to parse it as a date, it'll turn it into a date type.
During read.
Do that, so
Okay.
we just look through all the columns and say, like, if it looks like a date, make it a date? Or do you have to know which one?
All of them will become
I
a
think
date.
there might be, but for some reason it wasn't ideal. Like maybe it took lots of time, or it didn't always work, or for some reason I had to list it here. I would suggest checking out the docs for pandas.readcsv, and maybe on the forum you can tell us what you find, because I can't remember offhand. Good telephoning.
So how about the time zone? Like, how can we get the time zone?
Let's do that one on the same forum thread that Savannah creates, because I think it's a reasonably advanced question. But generally speaking, the time zone in a properly formatted date will be included in the string, and it should format it. It should pull it out correctly and turn it into a universal time zone. So generally speaking, it should handle it for you.
Hey, welcome back.
So I noticed you.
We want to see if there are patterns based on the day of the week, month, year, which all encapsulated in the date. And the thing that I found interesting is that I mean, I haven't trained many models, but even when programming, you're like, I can always access this type of information because it's in there, but he's putting it, like adding new columns to his table, I think, right? It's cool that he's just dragging that information out, making one table, one column of date into all of this other information. I think that's a good idea that is simple enough, like obvious enough, but not everyone thinks of, right?
For indexing a column in English, they use the F dot and the EF. Is there any consideration?
df data frame?
The square brackets one is safer, particularly if you're assigning to a column. If it didn't already exist, you need to use the square brackets format, otherwise you'll get weird errors. So the square brackets format is safer. The dot version saves me like a couple of keystrokes, so I probably use it more than I should. In this particular case, because I wanted to grab something that had field name had something inside it, wasn't the name itself, I have to use square brackets. So square brackets
Square
is
bracket one is more
your
our
safe bet
style.
if in doubt.
Yeah.
So after I run that, you'll notice that dfraw.columns gives me a list of all of the columns just as strings, and at the end, there they all are. Right? So it's removed, say.
Exactly. Feature engineering, getting attributes and features out of the already existing information. Now I get what it is. But also data processing is the bigger, high-level word. Yeah. By the way, I'm really happy that my internet is good today. Okay. List of columns. Okay. This is the data part 1. We ran this, but not this. Okay.
Our date, and it's added all those. So that's not quite enough. The other problem is that we've got a whole bunch of strings in there, right? So we can just leave that there. Do you want to pass it back? Pass it back. Thanks. So here's like low, high, medium. Thank you. Right. So Pandas actually has a concept of a category data type, but by default it doesn't turn anything into a category for you. So I've created something called
Like
train
lookup
cats,
table?
which creates categorical variables for everything that's a string. Okay, and so what that's going to do is behind the scenes it's going to create a column that's actually a number, right? It's an integer, and it's going to store a mapping from the integers to the strings. Okay. The reason it's train cats is that you use this for the training set. More advanced usage is that when we get to looking at the test and validation sets, this is a really important idea. In fact, Terence came to me the other day and he said, my model's not working, why not? And he figured it out for himself. It turned out the reason why was because the mappings he was using from string to number in the training set were different to the mappings he was using from string to number in the test set. So therefore in the training set, high might have been 3, but in the test set it might have been 2. So the two were totally different, and so the model was basically
confused.
Okay. So I have another function called apply categories, where you can pass in your existing training set and it'll use the same mappings to let
That's
make
actually
sure your
really
test set or validation set uses the same mappings. Okay. So when I go train cats, it's actually not going to make the data frame look different at all. Behind the scenes, it's going to turn them all into numbers. We finish at 11:50. Let's see how we go. I'll try and finish on time. So you'll see now, remember I mentioned there was this .dt attribute that gives you access to everything assuming it's a date time about the date time. There's a .cat attribute that gives you access to things assuming something's a category.
Really?
Right? And so usage band
This is an already
was a
existing
string,
thing?
and
I didn't
so now
know
that I've
that.
run train cats, it's turned it into a category. So I can go dfraw.usageband.cat, right? And there's a whole bunch of other things we've got there. Okay. So one of the things we've got there is .categories, and you can see here is the list. Now one of the things you might notice is that this list is in a bit of a weird order: high, low, medium. The truth is, it doesn't matter too much.
There's no order, no.
But what's going to happen when we use the random forest is it's actually going to, this is going to be 0, this is going to be 1, this is going to be 2, and we're going to be creating decision trees. And so we're going to have a decision tree that can split things at a single point. So it would either be high versus low and medium, or medium versus high and low. That
so it
would be
doesn't
kind of
matter.
weird, right? It actually turns
Really?
out not to work too badly, but it'll work a little bit better if you have these in sensible orders. Okay, so if you want to reorder a category, then you can just go cat.setCategories and pass in the order you want and tell it it's ordered. And almost every pandas method has an in-place parameter, which rather than returning a new data frame, it's going to change that data frame. Okay, so I'm not going to do that. Like, I didn't check that carefully for categories that should be ordered, but this seems like.
So it will update this instead of saying equals df raw. I mean, the usage band thing. I see.
Pretty obvious one.
Can you reiterate that issue? I don't understand.
That was cute.
Sure. So the usage band column is actually going to be this is actually what our random forest is going to see. These numbers 1, 0, 2, 1. Okay, and they map to the position in this array.
There's
and
a
as we're going
minus
to learn
one.
shortly,
Why
a
is
random
that?
forest consists of a bunch of trees that's going to make a single split, and the single split is going to be either greater than or less than 1 or greater than or less than 2, right? So we could split it into high versus low and medium, which that semantically makes sense. It's like, is it big? Or we could split it into medium versus high and low, which doesn't make much sense, right? So in practice, the decision tree could then make a second split to say like medium versus high and low, and then within the high and low into high
Not
and low.
always a bad
But
thing.
by-
It's better to keep a copy of the unprocessed raw data if you have enough memory just in case. True. If not, like if not in the code you're running, have it as a file at least, so that you can call it again, right?
Putting it in a sensible order, if it wants to split out low, it can do it in one decision rather than two. And we'll be learning more about this shortly. Honestly, it's not a big deal, but I just wanted to mention it's there, and it's also good to know that people, when they talk about like different types of categorical variable, specifically you need to know there's a kind of categorical variable called ordinal, and an ordinal categorical variable is one that has some kind of order, like high, medium, and low.
Ordinal. Wow, I studied that, but I forgot what it meant. If you're a bit familiar with functional programming, it's always better to return a copy rather than the input. I think, God, I had that issue with Java. It would always update my current existing thing, but I wanted it as a new thing. God, that was a problem for me.
Right? And random forests aren't terribly sensitive to that fact, but it's worth knowing it's there and trying it out.
Still ordering wouldn't help our maximum depth for everything.
That's what I'm saying. It helps a little bit. Right? It means you can get there with one decision rather than two.
I noticed there was a -1.
Yeah, I also noticed it.
Categories, is that like an NA or?
Yeah, the struggle. Like, Java is fine, it's great, but it has so many things that you have to do it its way. All of the references. Like, when you say just creating a new object of the current existing object that is not a reference of it, that gave me nightmares. Maybe I didn't know how to do it, but even Stack Overflow sometimes, I don't know, putting it in a different bucket and then initializing it in a new bucket, still it's a reference. I updated, the old thing updates. No, you know?
Yeah, exactly. So for free, we get a -1, which refers to missing. And one of the things we're going to do is we're going to actually add one. Can somebody pass it back to Paul? We're going to
Missing.
add one to our codes. Maybe in two goes. Let people know it's coming. Yeah, so let people. We're going to add one to all of our codes to make missing 0 later on.
So for the category for
but these categories is basically mapping strings to different integers.
That's right.
So there's one built-in function in Python is called get dummies. So basically for high, medium, low, there's like 3 columns.
Yeah.
High, 0, 1.
We're going to get to
So
that.
what is the
Yeah.
difference between this?
Yeah, so get dummies, which we'll get to in a moment, is going to create 3 separate columns. Ones and zeros for high, ones and zeros for medium, ones and zeros for low. Whereas this one creates a single column with an integer, 0, 1, or 2.
Yeah, so
That is
the
better,
difference,
isn't it?
like how should
One
we choose?
column.
We're going to get to that one shortly. Yep. Did you have a question too, Paul, or you're just pointing out? Okay. Okay. So at this point, as long as we always make sure we use .cat.codes, the thing with the numbers in,
.cat.codes.
we're
Okay.
basically done. All of our strings have been turned into numbers. Our dates have been turned into a bunch of numeric columns, and everything else is already a number.
Really?
Okay?
Usage bound was
The only other
thing
main
that
thing we
wasn't.
have to do is notice that we have lots of missing values.
Mm.
So here is df_raw.is null. That's going to return true or false, depending on whether something is empty. .sum is going to add up how many are empty for each series. And then I'm going to sort them and divide by the size of the data set. So here
Percentage.
we have some things which have like quite high percentages of nulls. So missing values, we call them in.
What happened?
Or
Why did it lose?
did I call it? Or maybe I didn't run it. There we go. Okay. So we're going to get to that in a moment, but I will point something out, which is reading the CSV took a minute or so. The processing took another 10 seconds or so. From time to time, when I've done a little bit of work I don't want to wait for again, I will tend to save where I'm at. So here I'm going to save it. And I'm going to save it in a format called feather format. This is very, very new.
Oh.
But what this is going to do is it's going to save it to disk
Not
in
pickle?
exactly the same basic format that it's actually in RAM. This is by far the fastest way to save something and the fastest way to read it back, right? So most of the folks you deal with, unless they're on the cutting edge, won't be familiar with this format, so this would be something you can teach them about. It's becoming the standard, right?
Cool.
It's actually becoming something that's going to be used not just in pandas, but in Java, in Spark, in lots of like things for like communicating across computers, because it's incredibly fast.
That's
And
really
it's
cool.
actually co-designed by the guy that made Panthers, by Wes McKinney. So we can just go df_raw.toFeather and pass in some name. I tend to have a folder called temp for all of my like as I'm going along stuff. And so when you go os.makeDirs,
sorry.
you can pass in
I
any
didn't see your
path
message.
here you like.
Feather
It
file at
won't
work recently. It's another brand new form like pickle. That's pretty cool. I didn't know that. I'm actually learning about this for the first time. I've been away from software engineering for a while. So it's good that I'm like learning things now. I never want to stop learning, honestly. No. Looking for something. There. Okay, found it. There. Okay, let's go back.
Plain if it's already there, because I've got exists OK equals true. If there are some subdirectories, it'll create them for you. So this is a super handy little function. Okay, so it's not installed. So because I'm using Kressel for the first time, it's complaining about that. So if you get a message that something's not installed, if you're using Anaconda, you can conda install.
Definitely. Glasses look like my glasses. Yeah, it's never too late. Never stop learning.
Kressel actually doesn't use Anaconda, it uses pip.
He's using it not locally, okay. But he still has to download it.
So we wait for that to go
stop.
along.
Sorry.
Okay, and so now if I run it, and so sometimes you may find you actually have to restart Jupyter. So I won't do that now because we're nearly out of time. So if you restart Jupyter, you'll be able to keep moving along. So from now on, you don't have to rerun all the stuff above. You could just say pd.readFeather, and we've got our data frame back.
Cool.
So the last step we're going to do is to actually replace the strings with their numeric codes. And we're going to pull out the dependent variable, sale price, into a separate variable. And we're going to also handle missing continuous values. And so how are we going to do that?
The other one was categorical.
So you'll see here, we've got a function called procdf.
We were just looking at how many
What is
missing
that?
values we
Procdf.
had. Okay.
So it's inside fast.ai.structured again.
Procdf.
And here it is. So quite a lot of the functions have a few additional parameters that you can provide, and we'll talk about them later. But basically, we're providing the data frame to process and the name of the dependent variable, the y field name. Okay, and so all it's going to do is it's going to make a copy of the data frame.
Nice.
It's going to grab the y value.
Target
it's going to
value.
drop the dependent variable from the original. And then it's going to fix missing. So how do we fix missing?
Missing.
So what we do to fix missing is pretty simple. If it's numeric,
Okay.
then we fix it by basically saying
0.
let's first of all check that it does have some missing. Right? So if it does have some missing values, so in other words the isNull.sum is non-zero, then we're going to create a new column called with the same name as the original plus underscore NA, and it's going to be a Boolean column with a
Yes,
1
no's. Okay.
anytime that was
So
missing,
you can filter it
and
out.
0 anytime it wasn't.
Is that a useful thing?
We're going to talk about this again next week, but this is, I'll give you the quick version. Having done that, we're then going to replace the NAs, the missing, with the
Missing
median.
categorical values.
Okay, so anywhere that you-
Sometimes. Solution is to add another categorical value called unknown, for example. Yeah. Like none, unknown, NA. Yeah, that's true. Instead of empty. Agreed.
To be missing will be replaced with the median, or add a new column to tell us which ones were missing. We only do that for numeric. We don't need it for categories because pandas
He's replacing them with median. So we're just creating data. That's cool.
handles categorical variables automatically by setting them to -1. So what we're going to do is if it's not numeric and it's a categorical type, we'll talk about the maximum number of categories later, but let's assume this is always true. So if it's not a numeric type, we're going to replace the column with its codes, the integers, okay, +1, right? So by default, Pandas uses -1 for missing, so now 0 will be missing, and 1, 2, 3, 4 will be all the other categories.
Okay. Missing even that.
So we're going to talk about dummies later on in the course, but basically, optionally, you can say that if you already know about dummy values,
Mean, median, random, sample random from, or even like just, yeah, you're right. True, you could, depending on what you're working on. Yeah, which is why understanding the data is useful. Yeah.
Columns with a small number of possible values you can turn into dummies instead if numericalizing them. But we're not
What's
going
a
to do that for
dummy?
now. Okay, so for now all we're doing is we're using the categorical codes +1, replacing missing values with the median, adding an additional column telling us which ones were replaced, and removing the dependent variable.
So knowing what is a replaced value, that is a good idea. Okay.
So that's what procdf does. It runs very quickly. Okay, so you'll see now sale price is no longer here. Okay, we've now got a whole new variable called y that contains sale price. You'll see we've got a couple of extra blah underscore NAs at the end. Okay, and if I look at that, Everything is a number. Okay.
And the NAs tell us if they're NA
These
or not?
Booleans are treated as numbers. They're just considered as 0 or 1. They're just displayed as false and true.
That's good.
So you can see here, is it the end of a month? Is it the start of a month? Is it the end of a quarter? It's kind of funny, right? Because we've got things like a model ID, which presumably is something like, I don't know, it could be a serial number, or it could be like the model identifier that's created by the factory or something. We've got like a data source ID. Like some of these are numbers, but they're not continuous.
Yeah, they're
it turns
categories.
out actually random forests work fine with those. And we'll talk about
I don't know what that means. One hot encoding. I could Google it in a bit.
why and how and a lot about that in detail. But for now, all you need to know is no problem. Okay, so as long as this is all numbers, which it now is, we can now go ahead and create a random forest.
Woo!
So m.randomForest regressor. Random forests are trivially parallelizable. So what that means is that if you've got more than one CPU, which everybody will basically on their computers at home, and if you've got a T2 medium or bigger at AWS, you've got multiple CPUs. Trivially parallelizable means that it will split up the data across your different CPUs and basically linearly scale, right? So the more CPUs you have, pretty much it will divide the time it takes by that number. Not exactly, but roughly.
Pretty much. Okay.
So n jobs equals -1 tells the random forest regressor to create a separate job, so a separate process basically, for each CPU you have. So that's pretty much what you want all the time. Fit the model using this new data frame we created, using that Y value we pulled out, and then get the score. Okay, the score is going to be the R squared. We'll define that next week. Hopefully some of you already know about the R squared. 1 is very good, 0 is very bad. So as you can see, we've immediately got a very high score.
That's a pretty good score.
Okay.
So we have 4 categories. Oh, thank you for explaining. Sorry. 4 categorical values: up, down, left, right. Up gets encoded to. Oh, I see. I think he talked about it in a bit. Instead of it being one column, it's each category gets its own column. 1 in one column, 0s everywhere else. That's why it's called a one hot encoding. I didn't know the term for it. It's like creating a matrix in a way, but not really. That's very interesting and useful in maybe like trainings, probably. Having each feature be its own column is probably more useful than having one column for like all the categories. I don't know, I wouldn't know, but still. The model only deals with numbers. That's one way to convert categorical values to numbers. True. One way, yeah. Thank you.
That looks great, but what we'll talk about next week a lot more is that it's not quite great, because maybe we had data that had points that looked like this, and we fitted a line that looks like this, when actually we got one that looks like that. Okay? The only way to know whether we've actually done a good job is by having some other data set that we didn't use to train the model. Now we're going to learn about some ways with random forests we can kind of get away without even having that other data set. But for now, what we're going to do is we're going to split into 12,000 rows, which we're going to put in a separate data set called the validation set, versus the training set's going to contain everything else.
Okay.
Right? And our data set is
do you know
going to be
what is the size?
Sorted by date, and so that means that the most
40,
recent
50 something,
12,000
right?
rows are going to be our validation set. Again, we'll talk more about this next week. It's a really important idea. But for now, we can just
I'm going to be able to finish this video. I'm so happy.
Recognize that if we do that and run it, I've created a little thing called print score, and it's going to print out the root mean squared error between the predictions
for
and
example,
actuals.
yes, embeddings in NLP. Probably there has to be an NLP episode. That would be really cool. I am excited with all the hype and all that. It's cool to learn more about it.
Training set for the validation set, the R squared for the training set, and the validation set. And you'll see that actually the R squared for the training was 0.98, but for the validation was 0.89.
Okay, fair.
Then the RMSE, and remember this is on the logs, was 0.09 for the training set, 0.25 for the validation set. Now, if you actually go to Kaggle and go to the leaderboard, in fact, let's do it right now.
What is the current?
It's got private and public. I'll click on public leaderboard. And we can go down and find out where is 0.25. So there are 475
Whoa.
teams.
Whoa.
And generally speaking, if you're in the top half of a Kaggle competition, you're doing pretty well.
Oh,
So 0.25, here we are, 0.25.
100.
What was it exactly? 0.25, 0.2507.
07. Wow.
About 110. So we're about in the top 25%.
That's
So the idea, like,
amazing.
this is pretty cool, right? With no thinking
Yeah.
at all,
Wait,
using the defaults
some
of
processing,
everything,
obviously.
we're in the top 25%
No thinking at all.
of Kaggle competition. So, like, random forests are insanely powerful, and this totally standardized process is insanely good
I'm gonna
for
run
like
this.
any data set. So, we're going to wrap up, but what I'm going to ask you to do for Tuesday is like
With
take as
defaults,
many
basically, yeah.
Kaggle competitions as you can, whether they be running now or old ones or data sets that you're interested in for your hobbies or work, and please try it, right? Try this process. And
This is really motivating. Wow.
if it doesn't work, tell us on the forum. Here's the data set I'm using. Here's where I got it from. Here's like the stack trace of where I got an error. Or here's like, if you use my print score function or something like it, like, show us what the training versus test set looks like. We'll try and figure it out, right? But what I'm hoping we'll find is that all of you will be pleasantly surprised that with the,
Darn it.
hour or two of
doesn't matter.
information you got today, you can already get better models than most of the very serious practicing data scientists.
Wow.
Okay, great.
Most serious data scientists practicing. Wow. That was a diss, but a fun one.
Good luck, and I'll see you on the forums. Oh, one more thing. Friday,
Which is 2 days ago.
the other class said a lot of them had class during my office hours. So if I made them 1 till 3 instead of 2 till 4 on Fridays, is that okay? Seminar, oh, damn it. Okay, I have to find a whole other time. All right. I will talk to somebody who
deprecated,
actually knows
okay.
what they're doing, unlike me, about finding office hours. Thank you.
I wanna get the score.
Absolutely.
Okay. Lesson 1 finished. Wow. And at a perfect time. Okay. I still wanna run the whole thing. I can be here for the whole thing. I can be here for. Am I here? Is it still? I can be here for. Is it still running? Hello? No. Oh god, that was scary. I thought the stream ended. At least the random forest is still running. Yeah. But here's the thing. Yeah, I think it was the it went from one router to another for some reason. Okay, it's good. Connection is fine, but just like my stream settings said offline, you're offline, and that scared me very much. The thing that I like is that YouTube doesn't cut me off. Twitch would just end, but YouTube waits for a bit. Like it said, disconnected, please wait while we try to connect you. I mean, I can show you, it doesn't really matter, but while this is running, this is my settings. I just want to see things. I thought, no, I wouldn't do that. Okay, maybe. I mean, end stream button is a big red button. Why would I do that? This is taking a while, it doesn't, like, isn't it? Oh, no. See, failed to save draft. I think it was the internet issue. Do I need to refresh this? No, right? Should be fine. Oh, could be. Save? Just save? Where's the save? Just save. I don't want to save it as a new version. I just want to save. Sorry about that. I couldn't mute myself for a second. We mentioned this yesterday too. It looks like a better option than Twitch. Yeah, I can see that. Okay, let's try Ctrl S. Yeah. It's trying to save it on my computer. Alhamdulillah, thank you. Yarhamukallah, you know. I'm gonna stop this and just see if stop. Maybe this refresh thing would help. Whoa. Okay, do that. I have internet, but I really need to go in a bit. Still trying to delay it. Let's not do that. I can do that when I come back next time. Draft session waiting for Jupiter. I shouldn't have done this harsh refresh. It's still saying failed to save, that's why. Okay. Let's do the run before. Oh wow. Okay, let's see. How do I know where it is? Training one will take a while, so that's for sure. Okay, see? You didn't have to do that, but okay. I can pause some things. Okay. Why are we stuck here? Did we load? Did we not load? I don't want to pause it. Okay, I need to go now. Negotiations all done. At least the draft saved is working at the top. So, yeah. Okay, let's nicely end this. I love this headphone. Okay. Today was pretty fun. I learned quite a lot actually, watching like half of the lecture. And also with the help of our dear friend Mustafa here. So there's a likely chance of me coming back tomorrow and doing another 1 hour stream, because I think that will help me go through this faster. So that would be pretty cool. And yeah, when things go smoothly, I get super motivated. So, and the running, oh, it ran. Is that an error? I think we have an error. Ah, whoa, there's the one hot encoding thing. Even here. Okay. I'm gonna get back to this inshallah tomorrow if all goes well. And yeah, I'm excited about this. I'm excited about this learning. So wish me luck and see you next time. Okay, I don't know how to end this. Thank you. This was cool. I'm gonna do the ending in 5, 4, 3, 2, 1 because sometimes when I stop the stream, it looks like Where do you usually share your schedule? Thing is, I still don't have a super set schedule, but if you want to ask me, maybe ask me on Twitter. But I have my Twitter handle. Where's my mouse? Mouse. You can't see my mouse, but it's at the top, on top of my head. But also it's linked in the description and everywhere. But I will do my best to schedule the streams like at least 21 where did that come from, 24 hours beforehand at least, so that people can see if the timing works for them or not. I'll schedule it for tomorrow right now, and do my best to do it, okay? Alright, I mean right now as in when the stream ends, so that I can do that. Okay, thank you for being here. I'm really happy things are going pretty well, and inshallah we'll continue with this. So I will end the stream, and inshallah I'll come back tomorrow. So let's end this in 5, 4, okay, 3, 2, 1, bye.